a bit trying to get the highlights for you for tomorrow. So the thing that we are talking about today, we're going to look at stretching and shrinking our graphs. Now, you do not necessarily need to write all this down, so let's talk about what's important. Vertical stretching and shrinking. That happens when you have a number multiplied with your function. Okay, so just write down the highlighted parts.
So we can carry this on with our other numbers?
Yes. If that number is bigger than 1, that stretches our graph. If it is between 0 and 1, it will shrink our graph. We've talked about outside affects y, and it does what you think. So essentially, what you need to remember is if I have a number multiplied on the outside, I'm just going to take my y's times that number. It does what I think. So if it's on the outside, multiply your y. On the inside, it's going to change the x and does the opposite. So if there's a number on the inside, if that number is bigger than 1, it shrinks our graph. And if that number is smaller than 1, it will actually stretch our graph horizontally. So I want to, let me go to this slide right here. Okay, let's go through some of these. This first one, my parent function would be what? Yeah, x cubed, our chair. Okay, so points like 0 to the third is 0. 1 to the third is 1. Negative 1 to the third is negative 1. If you know what your graph looks like from that, you're done. If you need more points, you could do like 2, 8, and negative 2, 8. So do more points as needed. I just require 3. So then, if I look at this, that 1/3, that is on the outside. If I'm going to plug something in, first I would cube it. I wouldn't multiply the 1/3 until the very end. So outside is y, it does what you think. So it's like multiplying my y's by 1/3. I'm going to show you an option. You do not have to do this, but sometimes I have people that really struggle with this. And so you could write out your ordered pairs, if that helps you. And we said all this will do is take your y times 1/3, right? This should be outside is y, it should be a vertical shrink. So you would just take those y's times 1/3. So this point will become 1, 1/3. X stays the same. 0 times 1/3 is still 0. Negative 1 times 1/3 is negative 1/3. So writing out the points is optional, but it can help you see exactly what's changing it. You're just taking the y times 1/3. So if I plot those points, 1, 1/3, 0, 0, negative 1, negative 1/3. If you had done like 2, 8, it would become 2, 8/3. So all it's doing, vertically shrinking, it's like taking your graph and mashing it down. So it's getting shorter and fatter when we do that.
Do we have to explain what our graph is doing?
If I asked you to describe the transformation, you would tell me the vertical shrink.
So wait, that's shrinking because it looks like it's shrinking.
It's, okay.
Okay, stretching is up and, okay, wait, I got it now.
So vertical shrinking and horizontal stretching kind of look the same.
Okay.
Think about like if you take a rubber band. If I mash it down, it has to go somewhere, so it spreads out this way. So like a vertical stretch, if I took my rubber band and stretched it, it's going to get tall and skinny when I do that. Is that one okay? Let's try this next one. my parent function? Crap. 0, 0, 1, 1, negative 1, 1. You could do 2, 4, and negative 2, 4 if you wanted. Okay, what is my transformation this time? Is it vertical or horizontal? Horizontal because it's inside the parentheses, and inside does the opposite. So this 4 would actually shrink our graph. Now if you think about that, if you're going to take it and you're going to mash it in on the sides, what's going to happen to your graph? It's going to get tall and skinny, shouldn't it? If I'm compressing it this way. So, if you want to write out your ordered pairs, this is a great way to see what's happening. So these were the points I just graphed. Inside changes x and it does the opposite. So instead of taking my x times 4, what's the opposite of multiplying by 4? Dividing. You're going to divide your x by 4. So if I divide this, I would get 1/2. 0, 0 doesn't change. What's negative 1, 1 going to become? Negative 1, 4, 1. Negative 2, 4 would become? You're just taking those x values, dividing them by 4. Does everybody see where I got my new points? Okay. So inside is x. So I took the original ordered pairs and we changed the x. And inside does the opposite. So this said times 4, so I divided by 4. So in my new points, I just took those x's divided by 4. Right. Right. We're leaving our y's alone right now. Okay, so if I plotted these points, I've got 1/4, 1, 1/2, 4, 0, 0, negative 1/4, negative 1, negative 1/2, 4. So my graph got really skinny because we horizontally shrink. We came in from the sides and mashed it. I would like for you guys to try. Okay, so I'm going to give you a few minutes. If you get one of them done, great. If you get time to do both, that's great. So I just want you to try, and then we'll come back and talk about them. Okay. Is this inside or outside? Inside is x, and it does the opposite. So instead of taking my x's times, you're going to divide them. So we are starting with the absolute value. So 0, 0, 1, 1, 2, 2, negative 1, 1, negative 2, 2. So there's your parent function.
Okay. I guess I'm not understanding how I'm automatically get that parent function.
I just looked at this, it was an absolute value. So I did the T-chart in my head, kind of. Like the absolute value of 0 is 0.
For your parent function, you don't have to do anything with 0.25.
No.
You just have to like do whatever absolute.
Yes.
Those
Those are those graphs that we did in the last section, where I printed those notes for you and we just did T-charts and graphed all of them. Those are the ones we're going back to for our parent functions. Okay, this is inside. So you said change x, and it does the opposite. So I'm going to take my x and divide it by 0.25. So this would become negative 8, 2. Negative 1 divided by 0.25 is negative 4. 0 won't change. 1, 1 would become
4, 1.
and 2, 2 becomes
8, 2. I don't understand.
That's
How does that?
that's supposed to be.
I'll show you in a second why.
Why would make up 1? If you have 4.25s, it's like a quarter. 4 quarters make $1.
Dividing by a fourth is the same as multiplying by 4.
Do you get it?
So if I plot my points, I've got 4, 1, 0, 0, negative 4, 1. I don't have room to go out to 8, so I'm just going to stop at those 3. So we can see this is a horizontal stretch of my graph. I took it, you took these two, and you stretch it out side to side. It's going to get wider. Okay? Let's do one more. Have you guys already, has anybody done this one yet? What, x to the 4th wasn't necessarily one of our basic parent functions, but we could still work with it. Is this 5 horizontal or vertical? Vertical because it's outside, and vertical does what you think, so it's a vertical stretch. Okay, 0 to the 4th is 0. 1 to the 4th is 1. If you did 2 to the 4th, you would get 16, so I'm not going to graph that. Negative 1 to the 4th is 1. This just looks like a parabola. Okay, outside is y, does what it says. So I'm taking all my y's times 5. So I get negative 1, 5, 0, 0, and positive 1, 5. So this vertical stretch is like if I took my rubber band and stretched it up, it's going to make my graph get skinny. What questions do you guys have for me right there? Huh?
So our 5.
Yes.
How do you know if it's a stretch or a shrink?
So these definitions that we wrote down, basically, if it's outside, if you're multiplying by something bigger than 1, it's like making it, or y's get taller, so it's stretching. Smaller than 1 shrinks it. If you forget these, graph it and then tell me after looking at the graph, did it stretch it or shrink it? Okay. Other questions?
So the S product doesn't do anything?
It tells you the parent function, and that's all.
So like
Yes, ma'am. So outside is y, does what you think, so you're multiplying. Inside is x, it does the opposite. So on the x's, that's when you're going to end up dividing.
So our 5.
The other thing we are going to be doing, and again, you don't necessarily have to write all this down, is reflecting. If there is a negative on the outside, it's like taking your y's and making them negative, so it will reflect across the x-axis. A negative on the inside takes your x's and makes them negative, which would reflect across the y-axis. Okay, you did these last year. The only thing that we did not really do last year was the stretching and shrinking. We talked about it, but we didn't do a whole lot with it. The up, down, left, right, flipping, that part is all review. Okay, so we are going to graph negative x squared. So first step always is the parent function. What is our parent function here? X squared, our parabola. You know, you have 0, 0, 1, 1, 2, 4. Negative 1 squared is 1, negative 2 squared is 4, so that's your parent function. Then we have our transformation. So if there is a negative on the outside, what does that do? Flip or reflect across the x-axis. It's like taking all of your y values and making them negative. So if you're on the x-axis, when you flip, it doesn't go anywhere. But if you're at 1, 1, it would go down to negative 1. 2, 4 would become 2, negative 4. So it just takes your parabola and makes it upside down. Yeah, the flipping is not so bad. The left, right, up, down, flipping, no big deal. It's the stretching and shrinking that are kind of a headache. So you guys remember doing these?
Yeah.
Okay. Good. I'm going to give you guys one.
Never say that one loud.
Not that easy, huh? Okay, here's yours. Okay. So, negative on the inside makes x negative, so it flips it over the y-axis. So if I take my points and flip them over the y. Just making all of the x's in your order pairs negative. Alright, questions on that?
No, that was pretty easy enough.
Good.
I think it should stop there.
Pretty easy enough.
Me too, is my.
Okay. Let's do some more. Well, because I won't be here tomorrow, so I've got to get you prepped. Yes.
Yeah, you're right. We should do some. I don't know. I knew how to do that one. This one looks a bit challenging.
A bit tricky, but I love it.
Just a bit. We can handle it though.
How do we do the difference?
What's my parent function? Yes, ma'am.
Okay, so how are we going to know the difference between reflecting and stretching and shrinking?
Reflecting is when you have a negative.
Oh, okay.
Stretching and shrinking, you're multiplying by a number other than 1.
Okay.
Oh gosh,
Dang, you dropped my I thought the y-axis is negative, and then when it's the x-axis positive, but then look back up there and it's a negative, so how do we know?
Negative on the inside makes x negative, so that flips it across the y.
So if it's inside something,
Inside.
it's a y.
Mhm.
Outside it's an x.
Yeah.
So it's just the same as straight.
Okay. So what's my parent function? Cubed. 0 cubed is 0. 1 cubed is 1. If you want to, you can do 2 cubed is 8. Negative 1 to the third is negative 1. Negative 2 to the third is negative 8 if you want that many points. You have to have at least 3. Exact, Ava. Okay. So, let's talk about our transformations. What would this plus 1 do? Up 1. What would this minus 2 do?
Right.
So that's from Friday. What will the negative out in front do?
Flip on the x-axis.
Okay. So, here's what I'm going to do. I want you watching me so we can make sure we understand it. I'm going to take each point and I'm going to go through these things. The up and down is going to be the last thing I do. So if I'm at 0, 0 and I flip it, does it go anywhere?
No.
Alright, and then I go right 2, up 1.
Wait.
What was it, 0?
If you flipped it, wouldn't it be right that going that way?
No, that's why we're doing the flipping first. So like, if I'm at 1, 1, if I flip this over the x-axis, it goes down here. Then we go right 2, up 1. Okay, if I looked at 2, 8, if I flip that over the x, it goes down to 2, negative 8. Right 2, up 1. If I'm here at negative 1, negative 1, if I flip that over the x, it goes up here, right 2, up 1. If I'm at negative 2, negative 8, if I flip that over the x, it goes to positive 8, right 2, up 1.
It's going to be on the right side of the graph.
So, I see now.
It doesn't matter, babe, that's what I'm saying.
Didn't change the shape of it, it just moved it around. Okay. Questions there? If you take it step by step, we should be able to get there. Worst case scenario, especially with the stretching and shrinking, if those really throw you, what could you do to get exact points? Calculator will give you a rough sketch on exact points, but could you make a T-chart from the final one if you had to? Yeah. Transformations are going to save you a lot of time, but worst case scenario, if you have to do a T-chart, you can. All right, let's do this.
So we're not flipping it over.
There's no negative this time, so we are not flipping. So, what's my parent function? Yeah, square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. So there's my parent. All right. What will this minus 3 do?
Shift down.
What will this plus 2 do? What will this 1/2 do? Is it vertical or horizontal? Vertical. Vertical does what you think, so a 1/2 would shrink it. Okay. If
Okay, I don't know.
Do you have a question? So, if you need to, I'm going to talk about an option here. You could do all this at once. Since the stretching and shrinking seems to be the thing that we have the most trouble with, let's talk about just that part first. Okay? this vertical shrink. Vertical changes y and it does what you think. So you can write out your ordered pairs if you need to. Definitely not required. If you do that, is this changing the x or the y in those ordered pairs? The y. And it's going to do what we think, so I'm just going to take my y times a half. So 0, 0 stays at 0, 0. 1, 1 becomes 1, 1 half. 4, 2 becomes 4, 1. 2 times a half would be 1. 9, 3 becomes 9, 3 halves. Okay, that would take care of the 1 half. So let's start there. This 0, 0, I take times a half, I'm still at 0, 0. And then I need to move left 2, down 3. Okay, 1, 1. If I take it times a half, now I'm at 1, 1 half. And then what do I need to do to that point? Left 2, down 3. Okay. 2, 2, or 4, 2. When I took it times a half, my point is now at 4, 1. Left 2, down 3. Okay, then I had this point 9, 3. When I took it times a half, it's 9, 3 halves. Left 2, down 3. So I moved my graph over and it got a little shorter because I took its y's times a half.
Do people normally have trouble with
The stretching and shrinking, yeah, because we didn't really do it that much in Algebra 2, so it does take a little bit. That's why I really encourage you, if you need to, write out the ordered pairs. If it's outside, you do what it says to y. So if I have a 1 half on the outside, take your y times a half. If I had a 25 on the outside, you take your y times 25. Inside, x does the opposite. So if I had a 5x, I divide my x by 5. If I have a 3x, you divide your x by 3. So if you write out those ordered pairs, it really helps a lot, takes a lot of the confusion out of the stretching and shrinking. Okay. Other questions there? Okay. We are going to I'm going to jump to this. Actually, I don't want to look like that. Let's go to this. Okay, here is a graph of a function. I did not give you the equation, but I gave you the graph. I want to draw two different things. So the first thing would be y equals a negative f of x. If there is a negative on the outside, what does that do? It's like taking off your y's and making them negative, so it flips over the x. So 0, 0 wouldn't go anywhere. 2, 6 would go to 2, negative 6. 7, 6 would go to 7, negative 6. So that half of the graph, when I flip it, would look like this. Okay, if I flip this, that was at negative 1, negative 3, so it goes to negative 1, positive 3. Negative 4, 0, if you flip it, isn't going to change. So that would be our final graph. You just flip it over the x. MathXL has some questions like this on there. They give you a graph and they ask you to do a transformation. So that's why we're practicing these. Let's do this one. if there is a negative on the inside, it makes your x negative. So it flips over what? The y. So if I'm back to this blue one, okay? 0, 0, if you flip it over the y, does it go anywhere? No. 2, 6, if I flip it over the y, goes to negative 2, 6. 7, 6 would go to negative 7, 6. So that portion of the graph looked like this. If I flip that over the y, it goes to positive 1, negative 3. Negative 4, 0 would go to positive 4, 0. So it's just giving those mirror images. Okay, so I might ask you to do transformations from pictures instead of equations to make sure that you understand what the transformations are telling you. Questions there?
You're going to type that in a special way for SL.
You would have to use their graphing tool, so like it will let you plot points and then draw the lines in that way. Some of these are going to be multiple choice on the Math Excel too, so it might give you 4 graphs and say which one is correct. All right. I am going to use every last minute today, so I'm going to do one more example. Okay, so this figure shows 2 views of the graph, y equals absolute value of x, and another graph illustrating a combination of transformations. Find the equation. Okay, so basically, here's my parent function. I want an equation for this red one. Let's start with the basics. How did you move this graph?
Right, 3 down
Do you guys agree with that? So my parent function was the absolute value. If I go right 3, how do you do that in the equation?
to minus 3.
Minus
And then down 2. Okay, so if I took this point and right 3, down 2, that's correct. If I took 1, 1, right 3, down 2, that does not match, does it? Okay, so this graph got skinnier. Okay, if I just moved this right 3 and down 2, I would be at negative 1. But where is the actual point at? Positive 1. So I had to take my y times something, didn't I? Okay, well, let's just try something. Would it be a number bigger than 1 or smaller than 1? If you're going to do vertical on the outside, if you look back at the very first thing we wrote down, vertical stretching to make it taller, you'd take your y times something bigger than 1. So let's just try. What if I put a 2 here? Okay, this would start here. If you take your y times 2, this is currently a y value of 1, 1 times 2 would move it up to 2. Then if I went right 3, down 2, does it match up? No, I need something bigger. So what else could I multiply by? Let's try 3. See if that works. So it started with a y value of 1. 1 times 3 is 3. If I go right 3, down 2, does it match? Yes. You could verify with some other points. If I took this times 3, it would go up to 3. Right 3, down 2. It does match up. So we found our equation. So you might have some where it asks you, gives you a graph and you're trying to write an equation from it. So it might take a little guessing and checking to get there. All right. So let's talk a little bit about from here. You guys have the current Math Excel, the 2.2 that's due by the end of the day today. So if you don't have that done, get that done. The 2.3 Excel is open. That is due on Wednesday. So that'll give you time to ask me questions when I get back on Wednesday. If you have questions in the meantime, feel free to shoot me an email, come see me before or after school. I will answer those. On Wednesday, we are going to continue to do